Hello and welcome to our Science and Space channel. Today, we're going to talk about one of the most mysterious and exciting topics in the universe, dark matter and the incredible collisions between galaxy clusters. Are you ready to embark on a journey that will inform and inspire your curiosity about this topic? Let's get started. By observing the complex and energetic collisions of distant galaxy clusters, astronomers have discovered that dark matter passes like a ghost through this gigantic debris. Unlike the normal matter we see, stars, planets, and moons, dark matter is the most mysterious substance in the universe. But what is this dark matter, and how is it detected? Dark matter cannot be directly observed because it hardly interacts with light or normal matter, but its presence can be felt through gravitational effects. Scientists know that galaxies are surrounded by large halos of dark matter that prevent galaxies from disintegrating. Dark matter makes up 85% of the mass of the universe, and so understanding it is crucial to unlocking the great secrets of the universe. The galaxy clusters studied in this research are part of a massive galaxy complex known as MACS J0018.5+1626, located about 5 billion light-years from Earth. Such structures are among the largest in the universe, and their collisions provide important information about the formation and evolution of the universe. The individual galaxies of the colliding galaxy clusters escape this cosmic accident unscathed thanks to the large gap between them. However, their dark matter content was much less affected. Emily Sillick, an astrophysicist at Caltech, suggests one way to imagine this collision. Imagine two trucks carrying sand and crashing into each other. Dark matter shoots forward like sand. Using data collected by NASA's Hubble and Chandra space telescopes, scientists were able to directly observe for the first time that dark matter is rapidly separating from normal matter. In addition to Hubble and Chandra, the research used data from the Caltech Submillimeter Observatory, the W.M. Keck Observatory, the Planck Observatory, the Atacama Submillimeter Telescope Experiment, and the Herschel Space Observatory. Since dark matter hardly interacts with light and normal matter, scientists can detect its presence through gravitational effects. We know that galaxies are surrounded by large halos of dark matter that prevent galaxies from disintegrating. Dark matter makes up 85% of the mass of the universe. Studying how dark matter separates from normal matter after this collision helps scientists better understand the nature and behavior of dark matter. Although dark matter cannot be detected directly, scientists can confirm its existence using gravitational effects and other indirect evidence. The MACS J0018.5+1626 collision is similar to the bullet cluster, but observed from a different angle. This angle allows scientists to measure the velocities of dark matter and normal matter. After the collision, dark matter and normal matter separate and move in different directions. Caltech professor Jack Sayers explains, "In the bullet cluster, we watch the cars move from left to right, like watching a car race. In our case, we use a radar gun to measure the speed of the car as it passes in front of us." Using data from Chandra, Sillick and his team determined the temperature and location of the hot gases of this collision. This data helped them understand how violent the collision was and how long ago it happened. The Chandra data revealed that this collision was one of the most energetic events in the universe. These collisions are among the most energetic events observed since the Big Bang. In such collisions, dark matter separates from normal matter and moves in different directions, providing important clues to understanding its nature. This research showed that the MACS J0018.5+1626 galaxy clusters were moving at about 7 million miles per hour, 11 million kilometers per hour, before colliding. This is about 1% of the speed of light. These incredible speeds and energies show how violent galaxy cluster collisions can be. Understanding why dark matter and normal matter move in different directions is related to the orientation of this collision and the separation of the two materials. This research hopes to open up new ways of studying dark matter. Scientists hope that such studies will help solve the mysteries of dark matter in the future. Don't forget to subscribe to our channel to explore this fascinating topic and more. If you have any questions, share them with us in the comments. This exciting research was published last month in the Astrophysical Journal. With studies like this, we will continue to discover the secrets of the universe. Did this video interest you? Would you like to learn more about dark matter and galaxy collisions? Share your comments with us and tell us which topic you would like us to cover in our next video. Thanks for watching. See you in our next video. Bye.